Hello. Solving linear inequalities. This is the last thing from this section. And what you're going to see is it's almost exactly like solving linear equations. Okay? There's just one little twist, and that's the thing you have to remember. So let's just set up what it is, how we talk about it, how we put the answer. Okay, so get that down. This is just a definition. That's what a linear inequality is. Inequality. It's an equation, except instead of an equal sign, it has a greater than or less than, or a greater than or equal to, or a less than or equal to. So, right, notice all those look exactly like linear equations. Ax plus b equals c, except it's not an equation. It's like it's not equal. It's not equal. It's either bigger than, or less than, or maybe, or equal to. So you know what the little bar under it means at this point. Okay, so what you're going to see is the way we solve them is almost exactly the same. So let's just talk about how we write them. An inequality like x is greater than 2 means that x can be any number greater than 2. So it can't be 2, but it can be 2.1 or 5 or a million or whatever. One way to visualize that is to draw it on a number line. So I'm going to go ahead and do that. And we just have to talk about the way we draw it. So here's a number line. Here's 0. Here's 2. What you do is, since x can't be 2, you know how parentheses mean it's included, but brackets mean it's not? You put a parenthesis here, and you essentially color in the number line. And then you draw a little arrow to indicate that that goes forever. Okay, so that's one way I could ask you to leave your answer. That's essentially how we graph that inequality. X can be any number that's in that filled in part, but it can't be 2. And that's why the parenthesis is important. If you put a bracket there, it would be wrong, and I'll show you that. Like this, if x is greater than or equal to 2, I know that seems like a finicky little thing, but it's important. It's important what things can and can't be. So here's 2. Instead of drawing a parenthesis, you draw a square bracket like that. Other than that, it's exactly the same. So that notation indicates to me that you know that x actually is allowed to be 2 in that scenario. Now here's another way to do that. This is called interval notation. Your book introduces something called set builder notation, which I'm not going to do. So if the homework asks you to do that, apologies, but you'll figure it out. So interval notation, you don't use a number line, you use parentheses and brackets like this. You have to know that symbol. You know that symbol, right? It means infinity. So one thing to get right off the bat here, infinity is not a number. Infinity is more like a concept or a cardinality. Don't worry about it. But you use that as one end of your interval to indicate that your interval never stops. So make sure you understand that. X being strictly greater than 2 corresponds to the interval 2, infinity, both of those things with curvy parentheses, not square brackets. So the curvy parenthesis around the 2 means that x isn't allowed to be 2. It's allowed to be 2.01, but not 2. The curvy bracket around the infinity, it's called a parenthesis. The parenthesis around infinity indicates to me that you know that infinity is not a number. So it's inappropriate to put a bracket on the infinity side, because that sort of implies that infinity is included in the interval or the solution set, but it's not, because infinity is not a number. X can't be infinity. It just indicates that it just never stops. So that's just convention, and that's just how we write it. And since you heard it here first, I want to get you in good habits for your future harder math classes. Okay. Similarly, if you write a negative infinity, that just means the other way. Okay, so the numbers never stop in the other direction either. There's no smallest number. So same thing, put a parenthesis around that end. So here's an example. If x were less than or equal to negative 2, the way you would write that, so this and this mean the same exact thing. I may ask you to write your answer on the test one way or the other, but know that if I ask you for interval notation, this is what I mean. And now that I'm thinking about it, I probably will. Okay, I'll ask you for interval notation, so I mean this. So make sure you remember what that is and that you dig how this corresponds with that. This and this mean the same exact thing. So this just says that x can be as small as negative as it wants. It can be negative a million, whatever. But it stops at -2. And there's even more information in there that it actually could be -2, right? X could be -2, and I know that you know that because of this bracket versus this parenthesis. Okay, so inclusive, non-inclusive. When I ask you to solve an inequality, just like in solving an equation, I'm asking you, what does x have to be for this to work? But when you solve an equation, thus far, you've just gotten one thing. X is 5 or whatever, right? When you solve an inequality, you're actually going to get an infinite amount of numbers, right? If x is bigger than 2, well, x can be 3 or 4 or 5 or a million or whatever. So now you know how to write that down with math notation, not just saying, okay, x is some number bigger than 5, but now you have a concise way to write that. Right, and when you solve these things, you're not technically getting a solution, right, or 2 solutions or 3 solutions. You're getting an infinite number of solutions, and that infinite set is called a solution set. Yes, a set can have infinite elements. Of course it can, like the set of integers or whatever. It does. So this is what I said up top. It's almost exactly the same. There's almost nothing you need to know except how to write it down. So we have this property, the addition property of inequality. This works exactly how you think it's going to work. If we have an inequality, we can add the same number to both sides. There you go. If A is less than B, then A plus C is less than B plus C. And if A is bigger than B, then A plus C is bigger than B plus C. And obviously that holds if A is less than or equal to. So everything we're saying holds if it's or equal to it as well. The only difference between those two things is in your answer is going to have a bracket instead of a parenthesis. Okay, so this just said we can go ahead and add or subtract, obviously. C could be negative, so we can go ahead and add or subtract any number we wish to both sides of an inequality and nothing happens. So there's no difference between this and if it were an equal sign. The only difference is how you're going to leave your answer. So subtract 3n from both sides, and then subtract 3 from both sides. And I did those both at once because we can do that now. Okay, so I moved the 3n over, and I moved the 3 over to the other side in one fell swoop. And I did it that way instead of the other way because 4n minus 3n is just n. And then you're just done. So you just have n is strictly bigger than 4. Okay, and assume, in fact, know that I'm going to ask you to use this notation on the exam. Okay, so I need you to know this. So 4 comma infinity. If you've ever seen like graphs that have points on them, like ordered pairs, like 2 comma 3 or whatever, they look exactly like this. So it's just an unfortunate thing in math where we use the same notation for 2 different things, but you know, we just do, so deal with it. But we haven't done that yet in this class. So when you see something like this, this means, if you had to say what this meant out loud, it means any number bigger than 4, but not 4. Okay? The other thing you can do that works exactly like it always has is you can go ahead and multiply both sides of an inequality by any positive number. And this is where we have to be a little bit careful. But if you have both sides of an equation or an inequality and you want to multiply both sides by 5 or 6 or 10 or whatever, go for it. Nothing changes. So just to illustrate that that works, here's a thing that's true. -2 is less than 5. Wouldn't you agree? If we multiplied both sides of that inequality by 3, we'd have -2 times 3 is less than 5 times 3. And then you look at it and say, well, is that true? Yeah, still true. Okay? And that is indeed the case no matter what. Here's the big however. if you multiply or divide by a negative constant, like -5 or -3 or whatever, you flip it around. So here's that rule, and I'll illustrate why it's true. So this you have to memorize, not word for word. You just have to know it. It's going to come up. So if A is less than B, or whatever, and C is negative, then if you multiply both sides of that equation by C, you see what I mean? It flips around. You have to reverse the inequality. It just goes the other way. Okay, so you have to know that. That will never go away. So that's what I mean. This is the one thing that's different in the actual algebra of solving an inequality versus solving a linear equation. So the same goes no matter what. There's 4 different cases, I guess, but it doesn't matter. If it's an inequality and you multiply or divide by a negative number, this happens. And that, again, that's the only difference now. If it were a nonlinear inequality, like a quadratic or something, that's a different ballgame, and we're not even there yet. So this is the one thing you have to remember, and I guarantee there will be one on the test where you have to multiply or divide by a negative number. So let me draw a picture to illustrate that, right? A picture is worth 1,000 words. So when you multiply by a number, so here's 2 and here's 4. I think we will all agree that 2 is less than 4. Okay, in this divided time, that's one thing we can all agree on. So now look at what happens if you multiply both of those by a negative number. If we multiply by a -1, here's what happens. Here's 0, here's 2, here's 4. If we multiply 2 by -1, we get -2. If we multiply 4 by -1, we get -4. So if you multiply both sides of that equation by -1, you have -2 and -4, except -2 is not less than -4. It's bigger. So what just happened? It jumped over it. This is the only way you can make an inequality flip, because the numbers jump over each other when you multiply them by a negative number. So all you have to know is that it flips around, right? We would all agree that -2 is greater than -4. So that's just one little example, but that's going to happen no matter what. And with all those other rules, this doesn't happen. If you multiply by a positive, they get bigger, but they don't jump over each other. If you add or subtract something, they just slide around. Okay? So that's why the multiplication rule for inequalities. I don't just want to tell you something and be like, it just is. Don't worry about it. I want you to see it, because this helps you. Now you just get it, and you remember that, oh, like they're going to flip. Okay. So just a simple example. If and when I ask you to solve something like this, you're just gonna. It's as simple as multiplying both sides by 1/9. If you think about that as dividing by 9, that's fine. You know, it's the same thing. You just got to do that. If you don't flip the inequality, I got to mark it. It's completely wrong. Okay. I take no pleasure in that. So on the left-hand side, you have just x, and on the right-hand side, you're going to have -5. And notice what I did. I flipped it around, right? This just now goes the other way. So you have x is less than or equal to -5. And you can verify that. So what I'm telling you is that any number like this works for this original equation. So yeah, just imagine, what if x is -6 or -10 or whatever. Plug -6 into this equation. -9 times -6 is +54. And we would all agree that +54 is bigger than or equal to +45. Right? So it works. Okay, so here's a little more complicated one. Like I said, I guarantee that something like this will be on the upcoming exam. So, except for that rule, this is going to proceed exactly like an equation. So there's just some more stuff. So 5 times parentheses 2x minus 1 minus 6x is strictly less than 11x minus 19. So do all the same moves you would as far as order of operations. Get rid of the parentheses. So distribute that 5, so it's 10x minus 5 minus 6x, and then combine whatever like terms you can. 10x minus 6x is 4x. 4x minus 5 is less than 11x minus 19. Now here's a trick. Here's a little trick for you. If I subtracted 11x from both sides, that would be a perfectly legit thing to do. Nothing wrong with that. But think about what you'd get. You'd get, okay, 4x minus 11x is -7x. Then thinking ahead, you'd have to divide by -7. Totally fine thing to do. But when you did that, you'd have to use the multiplication rule for inequalities, which again would work if you remembered to do it. But if you did it the other way, if you subtracted 4x from both sides, what would you get? You'd get a 7x over here. So, and then you would divide by 7, and then you would avoid ever having to use the multiplication rule for inequality. So I don't want to like let you get out of ever using it. You're going to have to use it. But be smart when you do algebra, right? There's not just one way to do it, but oftentimes there's a quicker, easier way to do it. Okay, so that's hot tip of the day. If you do that, so subtract the 4x from both sides and then go ahead and add 19 to both sides. Right, because the whole goal is to get x by itself. But it doesn't matter which side of the inequality it's on by itself. It can go either way. So I did that in one move. I subtracted the 4x from both sides and I added 19 to both sides. So now what do I got? I've got 14 is less than 7x. Now, right, we were smart and thought ahead. So now when we divide by 7, we're just donezo, right? It's just x is bigger than -2. Or really what this says is -2 is smaller than x, but I like to write it the other way. I actually wouldn't mark it wrong if you left it here, but while we're getting in good habits, just flip it around just because it looks nicer. And just think about, oftentimes with your answers, it's nice to just think about, like, how would you say this if you had to say it out loud in English? If you said -2 is less than x, that sounds weird. But if you say x is bigger than -2, that sounds more normal. Not that you're all sitting around talking about what numbers are bigger than other numbers in your daily lives. But this is a more common way to write it. And so I would get used to that. I like this better. So it's just how you're going to see it. So write it like that. And that's true with equations too. You don't really say 5 equals x, you say x equals 5. Okay, so say x is bigger than -2. And then you can go back and plug a number like, well, you could plug 0 in or whatever. Any number that's bigger than -2 into the original equation, right? Go all the way back to the beginning and verify that it works. Oh, yeah, and then I do want you to write it like that. So on the test, it'll say, leave your answer in interval notation. And I'm not going to tell you what that is, so you have to know that it's that. So any number bigger than -2 means a parenthesis, -2, comma, infinity. That just means it goes up forever. And let's do a quick word problem. A car rental costs $80 plus 28, so $0.28 is 28 cents per mile. How many miles can you drive if you got at most $100 to spend? So the trick here is just translating what does at most 100 mean in math, in mathese. You have to translate that to something. So at most $100 means it can be 98 bucks, 99 bucks, whatever. It can be $100, right? It says at most. It doesn't say less than. So at most $100 means you could spend exactly $100. So that means less than or equal to. I'm going to call, so the question is asking how many miles. So that's our variable. You could call it x. I decided to call it m. At most 100, that's the only thing that's new here really. It means less than or equal to 100. So what's our equation? 80 plus 0.28, so per means times in this case. So 28 cents for every mile you drive is going to be 0.28 times m is less than or equal to 100. There you go. So now you're not even going to have to use the multiplication rule. So this is going to just go down exactly like if it were an equal sign. It's just your answer is going to be different. So go ahead and subtract 80 from both sides. 0.28m is less than or equal to 20. And then you just divide both sides by 0.28. Gotta be careful. Is 0.28 positive? Yes. So you don't have to flip it around. 20 divided by 0.28, go ahead and use a calculator, is 71.43-ish. Now I rounded to 2 decimal places and I didn't say that in the setup. Assume on an exam it will be clear if I ever want you to round. And with story problems, like you generally do. So let's talk about that a little bit. If this were the real world, would you really be looking like, oh, have I gone 0.41 miles, 0.42 miles? No. If you'd figure this out and say I should probably go less than 71 miles, or you might even round it to 70 in real life. So like this is the answer. M is less than or equal to 71.43-ish miles. And so in reality, you want to be sure to spend less than or exactly $100, but you probably wouldn't want to mess with 0.43 miles. So you'd probably want to stop when you hit 71. Right, if you drove for 71 miles, you could plug that in, you'd be spending like $99 and change. So to be sure, you're probably not going to want to spend exactly $100 if this is the rule. So that's a more realistic answer. But on a test or something, M is less than or equal to 71.43 miles would be the correct answer. Okay, thank you.